A system of equations is it's a set of two or more equations that are related somehow or another, and we'll look at several different types, but let me just put up a couple of systems right here to start us off with. Yeah, and so we've got, two recognized, we've done these equations before, it's just now they're going to be together in a set, and so it's a system, we call it, a system of equations, and this is two linear equations, but they can be really of any sort of equation. The systems that we'll mainly deal with, I mean, we could throw in some logarithm equations and exponential equations, but the ones that we'll look at are more just polynomial type of equations. So here's another system. So we've got a linear equation and a quadratic equation. So, and we'll talk about what that might mean as far as solutions here. But let's first of all make sure we get the idea of a solution here. So a solution to a set, and now these are two equation systems with two variables. We'll talk about three variable equations and three equation systems later on, but yeah, so right now we're talking about two equation systems, and so a solution is an ordered pair. Usually we're talking x's and y's, we're talking equation, but the deal is, so it's an ordered pair, x comma y, that satisfies both equations, right? It's got to work in both. And so if I look at like this question, some of the problems in the homework, well, they'll have solutions for you to check, and so that's kind of what we're doing here. Is 0, 7 a solution to this system? X plus, make sure I got that right, yeah. X plus 2y equals 14 and 2x minus 3y equals negative 7. Is 0, 7 a solution? Well, the thing about 0, 7 is if we plug it into the top there, we'll have 0 plus 2 times 7 equals 14. That's true, isn't it? Because that's 0 plus 14, we got 14 equals 14. However, what about the second one? If I plug in 0, 7 for it, does it work there? 0 minus 21 equals negative 7? I don't think so, correct? And so the point is, it's got to work in both of them for this to be a solution. So is 0, 7 a solution? No, it is not. It has to work in both of them. And in this particular case, same system, and let's try 4, 5. So x is 4 and y is 5. Yeah, that works in the first one there, right? Because that's 4 plus 10, that's 14. But what about the second one? 2 times 4 minus 3 times 5. Yeah, that's going to work too, because that's 8 minus 15. And so that is negative 7 equals negative 7. So yes, that's the actual solution to that system. It works in both. Now I'll just mention on this second one I have here, both 2, 3 and negative 1, 6 are solutions. So it doesn't have necessarily just one solution. There can be more than one. 2, 3 and negative 1, 6 both work in that system right there. They work in both equations. If we plug them in there, check them. They both work. And so you can have more than one solution. And we'll talk about why you might have more than one, or if there's just one, or if there's not any at all. We'll talk about that more here in just a second, but that's the idea. So a system is just two or more equations linked together as a group, as a set. Now, there's two basic ways of solving systems, and we'll talk about both of them here. First way, let's talk about is the substitution. Solving systems by substitution here. All right, so 4x minus 3y equals 18, and y equals 14 minus 2x. So that's our system of equations. Yeah, this one is, and by design here I did this. This one's set up to do a substitution, because what substitution means is I can take, so the second equation is telling me the y is the same as 14 minus 2x. And so what I can do is replace y by 14 minus 2x in the other equation. So I can substitute the 14 minus 2x in for the y in the other equation. So that's why this is called substitution, because I'm going to substitute an expression for one of the variables. In this case, so 14 minus 2x goes in for the y there. And so what that does is that sets up that equation. That's just an x equation, so I can solve that for x now. You got 4x, just have to do a little distributing there. Minus 42 plus 6x equals 18, is that right? So I've got 4x, so I've got 10x minus 42 equals 18. Add the 42 and then divide by 10. 10x would equal 60. So divide by 10. We've got x is 6. Now the thing about these also is, that's just half the answer, isn't it? Because for a solution to a system, you need both an x and a y. And so the second part of this is to substitute the value of 6 in for x. And you can plug it in here, but it probably makes more sense, right, to plug it in for that second one. So I could plug in x to be 6 here or x to be 6 here to figure out the y, what the y is. So let's go with the bottom one there. Because we need that to finish off our solution here. Was that 14 minus 12? So y is 2. Yeah, so our solution, x is 6, y is 2. That would be the solution to this system. Okay? Now, the other thing I mentioned right now on the substitution, like if I did this one, 3x minus 5y equals 14. 4y minus x equals 1. If I wanted to solve that one by substitution, there may be other ways, but if I want to do this one by substitution, the thing about that one is it's not set up exactly like this one was, because this one we already had it set up for substitution. If I'm going to solve this one for substitution, I need to solve one of the equations first of all for one of the variables, don't I? I need to get one of the variables on a side by itself. Now, of course, we want to be smart about this, because if I choose one way, it's a lot easier than choosing another. For example, here, if I chose and I solved this one for y, the top one for y, or the bottom one for y for that matter, I'd wind up having some fractions. And so you want to make it as easy as we can. So it looks like here, let's solve the second one here for x, because that won't involve fractions. I won't have to get fractions involved there. So I've got 4y minus x equals 1. I'm going to solve that for x. However you want to do it, I can subtract the 4y, minus x equals negative 4y plus 1. then divide by -1, I've got my x equals, it would be 4y minus 1, right? So now, got it where I can substitute. Substitute that now for x. Take this back in the first equation, plug that in for the x. So that would be 3 times 4y minus 1 minus 5y equals 4. So now I've got just an equation that has only y involved. So I can solve that. Is that 12y minus 3 minus 5y equals 4, 12y minus 5y, 7y minus 3 equals 4. Yeah, this is going to work out. Add 3, you got 7y equals 7. So we divide by 7, that's y equals 1. But again, that's just half the answer. I also need the x. Well, if I go back here, like I said, you can substitute 1 wherever you want, here, here, or even here. Just make it easier on ourselves. Let's plug it in here. Because then all we have to do is evaluate that and see that x is 3. Yes? 3, 1 is the solution to that system. Again, we get one answer, one ordered pair. All right. The second type of method for solving systems is elimination. Would like for you to know both ways. Both ways are important. But let's solve a couple here by elimination. All right, so here's the idea. So let's take 2x plus 5y equals 4. 3x minus 4y equals negative 17. Let that be our system. So on elimination, the idea is I want to choose one of the variables, the x's or the y's, and eliminate those that variable by making the coefficients of that particular out here, and I'm going to eliminate the y's. And to eliminate the y's, what I need to do is make the numbers, the coefficients match, except one's a positive, one's a negative, right? And so in this particular case, I've got 5 and 4, and so it's the least common multiple of those, which is 20. So I want to make both of them 20, but one a positive 20 and one a negative 20. Because that, when the idea is I'm going to add these two equations together, and that will eliminate the y's. Because if I add 20y and negative 20y is what I meant by that. Because when I add them, they eliminate. That's the idea. All right, so I'll rewrite it here. Okay, so I need to make, I chose the y's to eliminate. So I need to make that 20, so I got to multiply it by 4. And I'm going to multiply the whole equation by 4. And so that'll make it 8x plus 20y equals 16. And so that's going to be 20, so I need this to be negative 20. Well, make that negative 20y, multiply by 5. And so that'll make it 15x minus 20y equals negative 85. Is that right? Thank you. Yeah, so now I've got those lined up. Well, they're going to eliminate. So the next step is go ahead and add those two equations together. 8x plus 15x is 23x. Y's will eliminate. And that's a negative 69, is it? Okay. Yeah, so now, in a little different way, now I just have a simple x equation to solve that for x. Divide by 23 is all I have to do, right? It's negative 3. All right, but not done because that's just half an answer. I need both the x and the y. Well, usually on these elimination ones, you don't have as nice a second to find the other variable as you do on the substitution, but that's all right. All right, so I just need to plug in either x is -3 here or here, doesn't matter. Looks like this one might be a little easier because, I don't know, they both will be about the same, looks like to me. Yeah. So now we just go back in and plug in x to be -3 in one of those. We got the y. That'd be -6 plus 5y equals 4, so to add the 6, and so that's going to mean 5y equals 10. Looks like y must be 2. -3, 2. All right. Now we do one more of those. Another one is elimination here, and then we'll talk about a couple other things. All right, so 2x plus 3y equals 17. And then 5x plus 7y equals 29. Yeah, so again, this one is set up for more for elimination. But what I wanted to say about this, we can eliminate either the x's or the y's here. And to me, it looks like the x's would be easier here because the x's have smaller numbers. If I go with the y's, I need 21, that's right. If I go with the x's, I would need 10s. And so I'm going to eliminate the x's just by choice. I mean, it doesn't matter, but just make a quick point about that. All right. Now, so both of them need to be 10s. So the top one I would multiply by 5. So that would give me 10x plus 15y equals 5 times 17 is 85. Okay. We had -85 a while ago. But the other point on this is I've got 5x, so I need to multiply by 2, but they need to be opposite. And so I also have to multiply that one by -2, don't I? So yeah, sometimes you might have to be multiplying by a negative to get the elimination to happen. All right, so it'd be -10x minus 14y. Well, that's going to work out nicely. Equals -58. X is to eliminate then. And the y's come out really nicely. 1y, or just y, equals 7. So we've got our y right there. Now we just have to figure out the x, plug in our 27 for y. And we got the x, 81, 17. I'm going to subtract the 81 and divide by 2. Is that 64? Divided by 2, so x is -32. So we got -32, comma 27 solution. Here again, get one solution. Which on those is typically what you get. Now, so what I'd like to talk about next is why am I just getting one solution here? Well, let's make it a little easier on ourselves here to do these, talk about these graphically, but kind of knowing the graphical situation here kind of explains why we get 1 or 2 or 3, how many ever solutions we get. Yeah, if you look at y equals 3x minus 5, y equals -2x plus 10. I guess, first of all, before we get to graphical here, if I'm going to solve this one, either method looks pretty good to me, doesn't it? I could do elimination, I could do substitution, either one. I just have to make if I wanted to use elimination, I can just make this multiply by -1. If I do the substitution, it's already, all I have to do is take that and plug it in there, right? So sometimes 6 of one, half dozen of the other, doesn't matter. So let's just go ahead and substitute, really about the same thing, I guess. Subtract 3x and subtract 10. So that's -5x equals 15. So divide by -5. X is 3, which would mean y is 3 times 3 minus 5. Substitute the 3. So y is 9 minus 5. Y is 4. 3, 4. So yeah, the question I want us to consider here, so why is there just one solution? Well, it has, one way we can answer that is the graph. Look at the graphs. Both of these are lines, and so we graph those lines there. Draw a pretty good XY axis here. So we got 1, 2, 3, 4, 5, 1, 2, 5. Straighter. So this will work out pretty good. Hopefully it'll work out pretty good. All right, so graphing that, however you need to, points, it's in Y slope-intercept form. So let me just do slope-intercept form here. Y-intercept's -5, slope is 3. So y is 3, run 1. All right, so something like that. And then y equals -2x plus 10, same thing. Let's see, 5, 6, 7, 8, 10. So there's my y-intercept of 10. Slope is -2, so down 2 over 1. A little finagling there, I got it where I went. All right, so yeah, why do we have just one solution? Well, it's where they intersect, isn't it? That's 3, 4 right there. Yeah, where they intersect is 3, 4. And so the reason they have one solution is because they intersect one time. If I have more than one intersection, then in our system, we'll have more than one solution there. So if I had if I had this, okay, so let's just say those are, we got, this is y equals f of x, this is y equals g of x, the line there. How many solutions does that system have?
3.
It's got 3 solutions, right? So if I have y equals f of x, y equals g of x system, that's the system there. It's got 3 solutions, yeah. Right here, and right there. So those 3 points would be solutions to that system, whatever they are. Figure them out if we needed to, okay? Or have a good idea. Now, the other thing I would mention is what happens on this one. What if I have y equals 2x plus 3 and y equals 2x minus 5. First of all, what's the solution there? Let's figure out the solution. What solution we got?
That's not gonna come out right.
That's not gonna come out right, you're right. Yeah, so if I do my little substitution thing there, looking the y to be 2x minus 5 in the top one, yeah, we've got a problem. Try to solve it like we normally do, what happens? 0 equals 8. Yeah, the x's cancel out, and so I wind up with an inaccurate statement there, 0 equals 8. Yeah, there's no solution to that particular equation, or for that matter, the system has no solution either. It's called an inconsistent system, by the way. I may ask you about that. The other question I would ask though, why does it have no solution? What happens on these lines here? The parallel lines, yeah. They don't intersect. This one, we got the y-intercept's 3, the slope is 2. So that would look like that. This one, the y-intercept's -5. The slope is 2. Same slope, and so yeah, these lines are parallel. And of course, parallel lines don't intersect. So that's why, yeah, in this particular case, there's no solutions because the lines don't intersect. You have to have an intersection for there to be a solution to our system, okay? All right, any thoughts or concerns on that?